Algebra 1 students, welcome to your 9.2 notes on quadratic functions. The big idea. In the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. And so they give us a function here in our notes. The axis of symmetry, x equals negative b over 2a. Where's our b value? It's right there. So we take that, we plug it into our equation here as a negative. So basically we change the sign. That goes in our numerator. 2a goes in our denominator, so 2 times a. That's how we figure out our axis of symmetry. In this section, we're also going to figure out where our vertex of our parabola is going to be. So we are going to take the axis of symmetry. We're going to plug that in for our x value, because basically the axis of symmetry is going to tell us where the vertex of our parabola is going to be on the x-axis. So we plug that value in for x. Then we take that and we plug it in to our function everywhere we find x. That gives us our f of x, or our y value. So some of you that have noticed that we all the time try to think about, hey, y equals f of x. Don't get intimidated by this. We're just plugging it in, and we're going to practice that coming up. All right, so here we go with number 1. So to find our axis of symmetry, what we're going to do is we're going to take our equation x is equal to negative b over 2a. All right, and I want to be in blue. Let's see if it does blue for us. So in this particular case, we have negative 6 as our b value. So b is actually going to be 6. See if I can make that look different than our b value sitting there. I know that that's difficult sometimes when we're doing board work. However, I think you guys can see that that's different. So 2 times 3 goes in our denominator. And in this particular case, we're going to end up with 6 over 6, which is equal to 1. All right. Where we figure out our vertex is we are going to take our axis of symmetry, which is going to be x is equal to 1. Okay. Let's go ahead and clean that just a little bit by writing x is equal to 1 for our axis of symmetry right down there. We're going to plug in x equals 1 into every single one of our x values. So we're going to plug that in as a function of our axis of symmetry, as a function of the x evaluated at 1. So here we go. 3 times 1 squared minus 6 times 1 plus 5. So this is going to equal 1 squared is going to equal 1. 1 times 3 is 3. And then we're going to have a 6 here. So 6 times 1 is 6. So we have 3 minus 6. And that's going to give us a negative 3. And then when we add 5 to that, we're going to end up with a value of 2. Now what do we do with that? We don't just leave it sitting there like that. We're going to actually list the vertex as an ordered pair, or as a point on our graph. So we plug in our x value for our axis of symmetry, which we got right there. We plug in our y value, or our f of x, evaluated at 1. All right, so number 2 is a little tricky. There's no b value sitting there. So let's figure this out. We've got a is equal to 4, b is equal to, well, 0, and then we have our c value is equal to negative 7. So we can still actually figure out where our axis of symmetry is going to be, because x is equal to negative b, which is negative 0 in this case, over 2a, so 2 times 4. We're still going to end up with 0. So our axis of symmetry is x equals 0. So here's what we're going to do in this case. We're still going to figure out what our function is evaluated at 0. So we we plug in f of 0. So that means that, again, that means every time we see an x, we're going to plug in 0. All right, so we have 4 times 0 squared minus 7. All right, we could tell pretty quickly we're going to end up with a negative 7. All right, and so we plug this in as a point, and this is going to be where the vertex of our parabola is going to be. We know it's going to open upward as well because this is positive, so let's remember that as well. A is positive, so that is how we evaluate the vertex, and that is how we evaluate the axis of symmetry. Let's move on to number 3. All right, here we go. We have our function here. Let's figure out what our axis of symmetry is going to be, and let's figure out where our vertex is going to be after that. So in this case, we're going to figure out that our axis of symmetry is negative b, so we have a 6 sitting here. So it's negative 6 over 2a, so 2 times 1/2. So in this case, we're going to end up with a negative 6 over 1, right? Because our 2's cancel out here. And basically that's gonna be the same as negative 6. Or we can also write this as x is equal to negative 6. All right, so remember that this is our axis of symmetry. We need to figure out where our vertex is going to be. So we're going to evaluate our function at negative 6. And basically, again, all that means is we're going to take negative 6, plug it in everywhere we find an x value. Here we go. All right, so I skipped ahead a little bit there, so you guys can pause it and check my work if you would like. But basically, when we plug in 6 for our x's, we're going to end up with negative 21 there, which is going to be the y value in our ordered pair, or in our basically evaluated for our vertex. So what we do is we create that ordered pair by plugging in the axis of symmetry for our x value. So we have negative 6, negative 21 is where our vertex is going to be for number 3. Here we go. We're going to graph. We're going to label the axis of symmetry and the vertex. So let's figure out where our axis of symmetry is going to be. X is equal to negative b. In this case, it's 8. So negative 8 over 2 times a, which in this case is negative 2. And we can tell that we're going to end up with a negative 8 over negative 4, which is equal to 2. So what we're going to do is plug that in for our function everywhere we find an x value. I went ahead and skipped some of my work there, but I think you guys get the picture. Your vertex is going to be at 2, 17. So here's what we're going to do in order to graph. We've got to pick a couple of x values. We've got to pick a couple of y values, or we're going to plug those x values into our function to figure out what our y values are going to be. And how do we pick what x values we're going to have? So what we're going to do is our axis of symmetry is at x equals 2. So we're going to just go a couple of directions away from there. And so if we choose the points 0 and 1, then that's where our axis of symmetry is going to be. And then if we pick 3 and 4, that'll give us a pretty good idea, or a pretty good picture of what our graph looks like. So in lines here, so that's going to be 20, 18. Our vertex should be somewhere right about there. The other thing that's interesting, I want to remind you guys from the first video from this section, is when we have a negative in the a value, that means that this graph is going to be opening up downward. Okay, it's not happy. Okay, if it's happy and it's positive, it would be opening upward. All right, so a little trick there that you guys might remember. All right, so if x equals 0, our y value equals 9. So let's see, 2, 4, 6, 8, 9 would be right about there. And then if x equals 1, it's going to be 15. So this graph is going to be kind of skinny here. And this is our axis of symmetry, so it's going to be pretty much the same values right on the other side of that axis of symmetry. let's change colors so that we can see what our graph looks like. Okay, it's going to look something kind of like that. Not sure where that little black spot came from. However, this is how we figure out our graph. We have to figure out our axis of symmetry, which in this case is 2, x equals 2. We have to figure out where our vertex is. Then if we plug in a couple of points, we can figure out what our graph looks like. But it doesn't look very nice, okay, because my handwriting isn't very good. And you guys have a tool that you're very used to using called Desmos. And that's what we're going to actually use for number 5 here. But I wanted to show you our t-chart and the reason why we came up with those values, because I feel like that's important in case you guys ever see that again. And it's important for you guys to understand into that while we're looking at Desmos as well. So here we go. On this one, we still need to figure out where our axis of symmetry is algebraically. So we're going to have x is equal to negative b. So in this case, that's 8 over 2a. So we've got 2 times 4 in our denominator. All right, we end up with a situation where it's 8 over 8, or x is equal to 1. All right, then what we do is we plug that in to our function, and we evaluate it at 1. So we're going to end up with some work here that I'm going to speed. As you guys are probably used to, I cut some of my work there because you guys know how to do it pretty well. We figured out that our axis of symmetry is x equals 1, and based on that information we can plug that in and figure out that our vertex is 1, 1. So instead of this one being graphed by hand like I did there, what I did was I figured it out on Desmos. So voila, there's what our graph should look like. There's our vertex. So that means that our axis of symmetry runs right along that x equals 1 line, cuts that puppy in half. Okay, it's happy. It's got a positive a value, so it opens up like a room without a roof. It's happy. So anyhow, that's what our graph should look like. Hopefully yours looks the same. Let's move on. All right, I want you guys to pause the video. And I mean pause the video. You need to pause the video. Do this problem on your own, and we'll come back. Ladies and gentlemen, I hope that you actually paused your video and did the work on your own. Here are the results that you should have gotten. So hopefully you did your work, but if you would like to check your results here, this is your opportunity. X should equal 0, or the axis of symmetry should be x equals 0. Your vertex should be at 0, 6. Let's see if Desmos agrees with us. And check it out. Our vertex is right at 0, negative 6 like we thought it would be. Our axis of symmetry means that the right side of the graph should look like the left side of the graph at x equals 0. So Desmos agrees with us. It looks a lot better than if I was to graph that by hand. And I'm glad that Desmos exists so that we can do said work. Ladies and gentlemen, that concludes your notes for 9.2. Hope you enjoyed yourselves. Have a good day.